You probably know intuitively what a tipping element means. It means you can push a system for a while and not much happens. You just push it a little bit further and it tips, just like a kayak when you go out and paddle out in Byron Bay. And you tip it a bit and it's fine, you tip it a bit more and it's fine. But if you tip it that extra little bit, it flips all the way over and you're underwater. A lot of the natural subsystems in the Earth system do the same thing. So here are some tipping elements. They come in three types: loss of major ecosystems like the Amazon, the northern forests, circulation change, El Nino, Atlantic thermohaline circulation, and so on, and importantly, melting of the big ice sheets. So how are we tracking? We're actually we're getting a lot of good information, a lot of good knowledge about these, so we can start talking about them. Amazon Basin. We've lost 10 years of carbon storage out of that from droughts in 2005 and 2010 and subsequent fires, which are unusual. But there's a double whammy. Not only are we seeing warmer, drier conditions in the Amazon, we're also eating away at it through human deforestation. And this double whammy is pointing now to a tipping element at around 2 degrees, where we would lose most of the Amazon forest. And that's a lot of carbon going back up into the atmosphere. That's why it's a tipping element. Permafrost starting to melt. How much could we lose? Well, the worst case scenario is 250 billion tons of carbon. That's 25 years worth of human emissions. If that starts going, and once it starts going, it'll become irreversible because it generates its own heat in the soil as it decomposes. So it's like a compost bomb, so to speak, ready to go off. If we lose that, there's no way we're going to stop at 3 degrees because that warming is going to trigger other things. We're losing Arctic sea ice. This is one where we think we've crossed the tipping point already. So this is summertime ice that covers the Arctic Ocean, keeps it cool. As it melts, it uncovers blue, dark ocean water, absorbs more sunlight, warms the ocean even more, melts more ice, warms the ocean even more. So you see how the tipping point works in that cycle. We think we've crossed that. We've lost too much already. So by the 2030s, most scientists are saying that's going to be ice-free in the Northern Hemisphere summertime. Coral reefs, I already talked about that. We think we've crossed the tipping point or are so close that we can't avoid it. So I think there's a death sentence for the world's coral reefs already. Here are the big ticket items. Greenland ice, that's the rate at which ice is being lost, increasing at a pretty fast rate. There's about 6 meters worth of sea level rise in that ice sheet. So that's a danger point. But the one that has really surprised us is Antarctica. We're starting to lose ice from West Antarctica at an increasing rate, and I don't have it. Even in the east, we're starting to see destabilization that we never predicted even 5 years ago. The bulk of the world's ice is here, south of us in Antarctica. If we lose, eventually, this and this, that's worth about 60 meters or so worth of sea level rise. Now that's not going to happen overnight. The maximum rate is about 2 meters per century that you're going to see, but that's an exceptionally fast rate of sea level rise. Now the interesting thing is that these tipping points have different sensitivities to temperature. So there's a group of them, we've talked about them. We've talked about Greenland, West Antarctic ice sheet, Arctic summer ice, coral reefs. In the Paris range, they could be tipped. And there's a whole group of them that up around 4 degrees get into danger zones. So the concern that we have is that these aren't going to act in isolation. We'll form what we call tipping cascades, where the most vulnerable ones, at 1 to 3, Greenland, Arctic, West Antarctica, coral reefs, will start tipping. In fact, they are starting to tip now. At the Paris target of 2, we'll lose more of them. But that will actually increase the temperature even further, which will start tipping the 3 to 5 degree ones, the boreal forest, monsoon, thermohaline circulation, Amazon, and so on. And then that could start tipping these dark red ones. So interestingly, the way we think the Earth system is going to operate is you're going to get the initial instabilities at the poles with the really vulnerable ice. The instabilities then will spread to the temperate and tropical zones and then spread back and hit the really tough ice at the poles. So the problem, we're trying to develop models to test this, is once we hit 2 degrees or so, you could actually generate a global tipping point that humanity cannot control. That once they start tipping in a cascade, like dominoes, you don't stop them.